Battery management software is very critical. The battery in the vehicle is the most expensive component, and therefore we need to make sure that we're managing that properly.
The whole point of the BMS algorithms is to reduce degradation, reduce aging, and increase the safety of the battery by monitoring it for anomalies.
It takes different data from sensors in the battery pack and allows it to monitor and maintain the overall battery performance by checking things like voltage, current, temperature, and it maintains the performance of the current.
Electric vehicle batteries are sensitive to temperature changes and either overcharging or discharging too much energy. These things need to be monitored and controlled in order to maintain the health of the battery.
Just like a normal engine has a spark plug controller and fuel injectors that's always controlling the engine for maximum efficiency and minimum emissions, we can do the same thing with the electric vehicle battery. We can monitor the battery in real time as the vehicle's driving, and we can control the motor drive and regenerative braking, the charging infrastructure, all the way up to fast charging, and control these things moment to moment.
So if all of a sudden it's pulling too much power, it can basically derate the battery and actually draw down the current to get the battery back into a safe area of operation. Our algorithms are physics-based, and that means we're predicting the actual chemical reactions that are happening in the battery. It's more of a predictive type of system versus the current systems that are more reactive.
We can see safety hazards before they happen, and we can monitor this for the life of the vehicle, and it can modulate its own performance. As the vehicle is used throughout its life, as you have different drivers having different behaviors or is using different environmental conditions, the algorithm's self-learning aspects will then recalibrate it on the fly through the life of the vehicle to accommodate for those.
Some people think that the BMS has to be located in hardware connected to the battery, but that's actually not true at all. If the BMS is containerized, it can actually run on any hardware. The best place for it is actually on the CVC, the Central Vehicle Controller, to take advantage of its computing power.
The BMS algorithms are going to remain on a virtualized machine, a VM, in a container on that CPU, and that way it will be isolated from all the other firmware aspects of the vehicle. We believe this is the best place for us to put our BMS algorithms because it allows us access to the vehicle data and also allows us access to the cloud network. We're also running our algorithms up on the cloud, and we can watch the vehicle for the entire life of the vehicle. In a fleet situation, we can also watch trends of multiple vehicles. Anything learned on one vehicle can be taught to all the other vehicles. And with this, we're using Wind River Studio with DFL for real-time parameter feedback and recalibration of the BMS on the fly from insights that we learn on the cloud. We can do live updates, and each one of the containerized virtual machines can be independently updated on the fly in real time.
We can more accurately ride the very edges of the performance of the battery. Take, for example, DC fast charging. That allows us to push more current into the battery over time and allows our customers to charge their vehicle at a much faster rate.
We're getting the maximum amount of charge with the minimum amount of degradation. Fast charging is where you're flooding the lithium battery with just lots of ions all at the same time. Our equations track the diffusion of the lithium ions into the electrodes. If you're charging faster than the electrode can accept those ions, you're aging the battery. Using our algorithms, we can predict the diffusion of the lithium ions into the electrodes, and we can control the charging right up to that limit. What we see today in North America and Europe are lithium cobalt style batteries. In the Asia Pacific region, they're using more of the lithium iron phosphate batteries. The further out in the future we get lithium metal batteries. Given the fact that our algorithms are based on a common set of physics equations, we can accommodate these market changes. They're all governed by the same laws of nature.
We understand how the entire vehicle works together. We understand how the BMS would live on the central vehicle controller, for example, and how it would communicate with the other devices and the other components within the vehicle.
Aptiv has the infrastructure and the capability competency to address the BMS market. Being involved in the high voltage architecture of the vehicle, combined with our smart vehicle architecture approach, we're in a very good position to address today's and tomorrow's BMS challenges.